The Engineering of Large Software Systems, Week 7, Strategies for Balancing Agility and Discipline. In this lecture, we will discuss the need for both agility and discipline when dealing with large complex systems. It makes sense that one needs to use multiple approaches to successfully engineer such varied systems. Discipline and agility go hand in hand. Discipline providing foundations, and agility able to act quickly to change. Neither is sufficient in and of itself. Both are needed. However, there is a heated discussion in software development about the two, and proponents of two different approaches to development have argued that one is more important than the other. While there is discipline and flexibility on both sides, the effectiveness of traditional and agile methods are at the center of this difference of opinion. In February of 2001, a number of leading software developers met at a ski resort in Utah and created the Agile Manifesto. While a simple statement of belief, it became a rallying point for a large number of developers who were concerned and frustrated over the emphasis on process that reached its peak in the 90s. The strident, near-religious debates that ensued created great perplexity in the software engineering world. Although there were lots of people interested in understanding, both sides were guilty of bending the facts to their own purposes. Purists and true believers abounded. Thankfully, cooler heads prevailed, and in the last few years there has been general consensus that both sides have advantages and disadvantages. Barry Boehm and I believed that there were home grounds for each approach where they were particularly effective, but we realized that there was a large spectrum between the two home grounds. We tried to capture all of the information we could and put together a risk-based strategy to find solid middle ground. We identified 4 areas where there were clear differences between agile and traditional methods: application, management, technical, and personnel. Differences in application of the methods include primary team goals, the size of the project where they were applied, the environment around the project, and the velocity with which the development proceeded. The differences in management were around customer relations, planning, and control approaches, and how each handled communication among developers. Technical approaches differed as to how requirements were identified and managed, the design approach, and the testing strategies. Finally, the kind of personnel needed to execute the approaches, including customers, developers, and organizations, were substantially different. By analyzing these differences and the home grounds, we developed 5 critical factors that can provide the basis for locating a project on the agile plan-driven scale. These factors are shown in this caveat or spider diagram, where home ground for agility is toward the center, and home ground for traditional plan-driven approaches toward the outside. We believe that most projects can be defined using these factors. We also believe that these factors can be used to get a general idea of the degree of fit for one or the other approach. We found 2 case studies that serve as exemplars for using this balanced method. One, an agile project that found it needed some more traditional ceremony, and the other, a traditional project that gained great success through applying agile approaches. In the first case, the organization had been having difficulty with development and turned to the Agile Extreme programming methodology to salvage the product. The project, however, grew out of the home ground of the method and needed to add some traditional practices to maintain order as the project grew in size and scope. In the second case, a traditional defense program needed to apply considerable flexibility to prevent the standard process from driving it to bad decisions and possible failure. As you can see from this composite diagram, both fall into the middle between agile and traditional characteristics. Using these characteristics as a guide, and falling back on Barry's belief that risk can be used as a fulcrum for decision-making, We arrived at a process that we believe helps projects understand where they fit in this Agile plan-driven spectrum and how they might want to approach balancing the Agile and traditional methods applied. The process involves identifying and comparing risks associated with each method, deriving an appropriate architecture and life cycle, and monitoring project execution so that the balance can be maintained. The risks we use in the process consider the project's environment, the risks of applying Agile methods, and the risks for applying traditional plan-driven methods. Let's walk through an example of a large, complex system to show how the process is applied. The National Information System for Crisis Management, NISCM, is being developed to support a broad coalition of independent agencies that need to coordinate during national crises. These crises include natural disasters, financial, biomedical, and weapons-oriented crises, and crises involving the national infrastructure of transportation, communication, information processing, and the distribution of electricity, energy, and other critical resources and supplies. The NISCM will use the best of modern information technology to support cross-agency and public-private sector coordination of crisis management activities. Besides modern adaptive mobile network technology, virtual collaboration technology, information assurance technology, and information integration technology, the use of agent-based planning and monitoring technology is a major NISCM solution component. The acquisition strategy is to have a private sector system of systems integration contractor develop the infrastructure of the system and then acquire or build the various functional capabilities. The project is expected to take a decade to complete. Filling out the caveat diagram for NISCM, it is clear that while the predominance of the characteristics are clearly in the plan-driven home ground, the dynamic nature of the system and environment support the possible use of Agile approaches. Here's how we evaluated the risks involved in developing NISCM and how we identified mitigations for those deemed critical. It is clear that the risks follow the same pattern as the caveat. The NISCM lifecycle is based on the risks and the mitigation strategies. We'll look more closely at large system lifecycles later in the course. Suffice it to say that the lifecycle shown here is much more complex than one for a smaller, less demanding development. In doing our research, Barry and I arrived at several observations about the balance of traditional and Agile approaches. Some of these actually echo our earlier discussions in class about complex systems in general. First and foremost, there is still no silver bullet. Second, there are clear home grounds for each approach. Third, the nature of the systems being developed increases demands for agility, velocity, and quality. Fourth, balanced methods are emerging. Fifth, it is better to tailor development processes, starting with the minimum and adding ceremony as needed, rather than tailoring down from a full-blown standard. Finally, and perhaps most important, is that processes and methods, while important, do not usually drive success. The people involved do. People bring values to the process. They communicate in a broad variety of different ways. And they set expectations for the system regardless of what may be stated in requirements or specifications. People are truly the most important factor in project success.